NVIDIA has been making waves with its groundbreaking AI technology, but there's more beneath the surface than meets the eye. While many are focusing on the current market trends, Jensen Huang sees an AI revolution that's just getting started. So, what's really driving NVIDIA's explosive growth? And why is Huang so confident that we're only at the beginning of a multi-trillion-dollar AI boom?
You went into great detail about what's happening, particularly in China. I just wanted to go over something that I felt wasn't asked, which is fiscal second quarter sales, $45 billion plus or minus 2%. $8 billion of lost revenue opportunity, specifically relating to China in H20. It seems as if you made up somewhere some demand for a different product or from a different geography or from a different corner of the market. What was that?
Well, we got a whole bunch of engines firing right now. The biggest one, of course, is the reasoning AI inference. The demand is just off the charts. You see the popularity of all these AI services now, ChatGPT, Gemini, so on and so forth, Grok. I mean, they're just doing incredibly well across the board. And all of the APIs that they serve out and all the agentic AI services that are built on top of them, they're all doing incredibly well. I think that there's just a giant breakthrough in AI's capability, and inferencing has just become a giant workload. Second, people realize that Blackwell is just a home run. NVLink 72 is a home run architecture. We designed it to be a thinking machine, a reasoning AI system, and I think people now, the confluence of the breakthrough in reasoning AI and the availability, the emergence of Grace Blackwell NVLink 72, perfect timing. I think that's at the core, a big part of it. And the second part of it is that our supply chain is growing and we're really ramping it up and they're doing fantastically for us. And so all of these things are all coming together.
And so it is fair to say that some of that additional supply on Blackwell and the demand for Blackwell kind of made up for the opportunity lost in China, at least in the outlook for this current period?
Yeah, I guess so.
All right, welcome to the Grok 4 release here. This is the smartest AI in the world, and we're going to show you exactly how and why. It really is remarkable to see the advancement of artificial intelligence, how quickly it is evolving. I sometimes compare it to the growth of a human and how fast a human learns and gains conscious awareness and understanding. And AI is advancing just vastly faster than any human. We're going to take you through a bunch of benchmarks that Grok 4 is able to achieve incredible numbers on. But it's actually worth noting that Grok 4, if given like the SAT, would get perfect SATs every time, even if it's never seen the questions before. And if even going beyond that to say like graduate student exams like the GRE, it will get near perfect results in every discipline of education. So from the humanities to like languages, math, physics, engineering, pick anything, and we're talking about questions that it's never seen before. These are not on the internet, and Grok 4 is smarter than almost all graduate students in all disciplines simultaneously. Like, it's actually just important to appreciate that's really something. The reasoning capabilities of Grok are incredible. So there's some people out there who think AI can't reason, and look, it can reason at superhuman level. And frankly, it only gets better from here. So we'll take you through the Grok 4 release and show you like the pace of progress here. I guess the first part is like in terms of the training, we're going from Grok 2 to Grok 3 to Grok 4. We've essentially increased the training by an order of magnitude in each case. So it's 100 times more training than Grok 2, and that's only going to increase. So it's frankly, I don't know, in some ways a little terrifying, but the growth of intelligence here is remarkable.
The rapid rise of AI has fundamentally altered the landscape of technology, and at the heart of this transformation is NVIDIA, led by its visionary CEO Jensen Huang. He highlights a tectonic shift, one that NVIDIA is helping to orchestrate. AI has evolved past the simple computational tasks it once handled. We're now in the era of reasoning AI. For the first time, we're seeing systems that don't just process data. They understand it, interpret it, and make decisions based on it. Huang mentions the surge in demand for services like ChatGPT, Gemini, and Grok. What's interesting here is how these AI services are creating an ecosystem. We're seeing an interconnected web of AI platforms that are feeding into one another, accelerating the development of each. But Huang doesn't stop there. He points to NVIDIA's Blackwell architecture, a system that has been meticulously designed to handle reasoning AI. This is crucial because while many tech companies are playing catch-up, NVIDIA is anticipating the future. Their Blackwell architecture is about designing systems that think, reason, and adapt, opening up possibilities for machines that work in ways that feel almost human. This is what sets NVIDIA apart because they're setting them. NVIDIA is at the forefront of this movement, and the market's demand is proof. The company's ability to deliver on this vision is directly tied to their technological innovation and strategic foresight. The future of AI is in the hands of companies like NVIDIA, and they're driving it.
Oh, but you can't underestimate the importance of the China market. This is the second largest AI market. This is the home of the world's largest population of AI researchers. And we want all of the world's AI researchers and all of the world's developers to be building on American stacks. And so, irrespective of the near-term revenue success that we have, we can't ignore the fact that the Chinese market is very important.
You explained, again, in some detail, that at least in the Hopper architecture, you have engineered down to the lowest spec possible. It's not possible to do anything different with Hopper for the Chinese market. But in your consideration for a different architecture or a chip for the Chinese market, is that what we're talking about, a new design or new class? And have you made that proposal to the administration, just designing from the ground up a new chip?
We're still thinking through that. The limitations are quite stringent, quite limited, if you will. H20 is as far down as we could take a Hopper. We don't know how to make it even less, and so that's really the limit. So there are main, the limitations are quite stringent. So we have to really think through it. Whatever we make ultimately has to add value to the market, and so it's a really tightrope because the Chinese competitors have evolved and advanced greatly over the last year. Like everybody else, they're doubling, quadrupling their capabilities every year, and the volume is increasing substantially. And remember, these are data center chips; they don't have to be small; they could be quite large. Without American technology, the availability of Chinese technology will fail the market. And so, whatever we offer has to at least be competitive and has to add value to the market.
Jensen, does Huawei have an AI accelerator or a GPU that is performant as H20 or is performant of other classes of GPU that you make?
Huawei's technology, based on our best understanding at the moment, and we have a lot of ground truth there, is probably comparable to an H200. And so they've been moving quite fast, and they've also offered this new system called Cloud Matrix that scales up to even a larger system than our latest generation Grace Blackwell. And so Huawei, as you know, is a formidable technology company, and they're not sitting still, and they look for ways to compete, and they're quite formidable.
With that in mind, you've kind of explained the landscape now, NVIDIA's ability to operate in China. I mean, you and I this year alone have already discussed the idea that there are 50% of the world's AI researchers in or from China. But are you having a sense of the vacuum created that those big names, I think about Tencent or Alibaba or Baidu, that were buyers of H20, that they've already pivoted and turned to the offering from Huawei because of the policy that is in place?
Yeah, they have no choice but to, one of the challenges of the changing regulations is the ability for markets to trust the NVIDIA and ultimately American platforms. And so it's prudent, I think, for the Chinese customers to make sure that they develop their stack on Huawei, and because it's hard to rely on American technology at this point. And so that's one of the unfortunate parts of changing policies. But anyhow, I have every confidence that if able to compete, American companies will compete. This is, to write off American technology companies is not smart. This is the home of some of the brightest computer scientists in the world. American companies are incredibly competitive. We just have to have the confidence to go compete. And if we have the confidence to compete, we will win.
Let's just talk about how smart Grok 4 is. So I guess we can start discussing this benchmark called Humanities Last Exam. And this benchmark is a very, very challenging benchmark. Every single problem is curated by subject matter experts. It's in total 2,500 problems, and it consists of many different subjects: mathematics, natural sciences, engineering, and also all the humanities subjects. So essentially, when it was first released, actually like earlier this year, most of the models out there can only get single-digit accuracy on this benchmark. Yeah, so we can look at some of those examples. So there is this mathematical problem, which is about natural transformations in category theory. And there's this organic chemistry problem that talks about electrocyclic reactions. And also there's this linguistic problem that tries to ask you about distinguishing between closed and open syllabus from a Hebrew source text. So you can see also it's a very wide range of problems. And every single problem is PhD or even advanced research level problem.
Yeah, I mean, there are no humans that can actually answer these, can get a good score. I mean, if you actually say, like, any given human, what's the best that any human could score? I mean, I'd say maybe 5% optimistically.
Yeah.
So this is much harder than what any human can do. It's incredibly difficult. And you can see from the types of questions, like you might be incredible in linguistics or mathematics or chemistry or physics or any one of a number of subjects, but you're not going to be at a postgrad level in everything. And Grok 4 is a postgrad level in everything. Like it's just, some of these things are just worth repeating. Like Grok 4 is postgraduate, like PhD level in everything. Better than PhD, but like most PhDs would fail. So it's better that said, I mean, at least with respect to academic questions, I want to just emphasize this point. With respect to academic questions, Grok 4 is better than PhD level in every subject, no exceptions.
Let's give a moment to the geopolitical landscape Huang touches on. The China question is one that looms large for any tech company with global ambitions, and NVIDIA is no exception. Huang doesn't mince words when he talks about the loss of revenue opportunities in China. As he rightly points out, China is home to some of the most talented AI researchers in the world. Losing access to that market would be a serious setback, but Huang isn't painting this as a simple problem. Instead, he's framing it as a challenge NVIDIA is equipped to face head-on. What's crucial here is how Huang emphasizes that NVIDIA is still looking for ways to serve the Chinese market, despite the restrictions. This speaks volumes about NVIDIA's long-term vision. They want to be a part of the AI ecosystem that's growing there. The geopolitical tensions around tech exports have created a kind of vacuum, but Huang's response is not one of defeat. Instead, he sees this as an opportunity to innovate within the constraints that exist. It's a careful balancing act, how to create value for the Chinese market while ensuring that NVIDIA's technology is still competitive on the global stage. Huang's approach shows us a side of business strategy that's often overlooked. It's about maintaining influence and setting up a platform that can compete globally, no matter the external circumstances. This mindset is what will allow NVIDIA to weather the storm and thrive in the long run, regardless of the political volatility.
You said during the earnings call that you trust President Trump and that the president has a vision and a plan Could I ask if you've talked to him about that plan and if it includes coordinating with NVIDIA on policy adjustment that relates to changes in technology export controls?
Well, obviously, I don't know all of his ideas, but let me tell you about two that are incredible. The first one is utterly visionary. The idea of tariffs being a pillar of a bold vision to reindustrialize, to onshore manufacturing, and motivate the world to invest in the United States, and is just an incredible vision. I think this is going to be a transformative idea for the next century for us. We're all in on the idea. We're setting up plants and encouraging our partners from around the world to invest in the United States, and we have a lot of stuff going on, and so I'm very excited about that. The second major idea is to rescind the AI diffusion rule, recognizing that this isn't about limiting American technology, but this is about accelerating American stacks around the world to make sure that before it's too late, that the world builds on American stacks during this extraordinary time, the AI era. And so these two initiatives are completely visionary, and it's going to be transformative for America.
Jensen, in the time that you and I have been on air having this conversation, some news has broken from US Secretary of State Rubio, who has said that the US will begin revoking some Chinese student visas. What I wanted to ask you is that with US government limits on foreign student visas, how does that impact a company like NVIDIA? I think about the size, but also composition of your engineering talent here in California and elsewhere in the United States.
I believe the administration still feels very strongly about the incredible importance of immigration. Look, I'm an immigrant. I know many immigrants that came to the United States to build a great life, and many of us have contributed greatly to the technology industry and the United States. I believe that's going to have to continue.
I guess we can talk about what's behind the scene of Grok 4. As Jimmy mentioned, we actually throwing a lot of compute into this training. You know, when it started, it's only also a single digit. Sorry, the previous slide. Sorry. Yeah, it's only a single digit number. But as you start putting in more and more training compute, it started to gradually become smarter and smarter, and eventually solved a quarter of the HLE problems. And this is without any tools. The next thing we did was to adding a tools capability to the model. And unlike Grok 3, I think Grok 3 actually is able to use CRO as well, but here we actually make it more native in the sense that we put the tools into training. Grok 3 was only relying on generalization. Here, we actually put the tools into training. And it turns out this significantly improves the model's capability of using those tools.
Yeah, I remember we had like deep search back in the days.
Yeah.
So how is this different?
Yeah, exactly. So deep search was exactly the Grok 3 reasoning model, but without any specific training, but we only asked it to use those tools. So compared to this, it was much weaker in terms of its tool capability.
And unreliable. Yeah.
And unreliable, right. Yes.
And to be clear, like these are still, I'd say, this is still a fairly primitive tool use. If you compare it to, say, the tools that are used at Tesla or SpaceX, where you're using, finite element analysis and computational fluid dynamics, and you're able to run, or say like Tesla does, like crash simulations where the simulations are so close to reality that if the test doesn't match the simulation, you assume that the test article is wrong. That's how good the simulations are. So Grok is not currently using any of the tools, the really powerful tools that a company would use, but that is something that we will provide it with later this year. So we'll have the tools that a company has, and have very accurate physics simulator. Ultimately, the thing that'll make the biggest difference is being able to interact with the real world via humanoid robots. So you combine sort of Grok with Optimus, and it can actually interact with the real world and figure out if it can formulate an hypothesis and then confirm if that hypothesis is true or not. So we're really, I think about like where we are today. We're at the beginning of an immense intelligence explosion. We're in the intelligence Big Bang right now. And we're at the most interesting time to be alive of any time in history. Yeah. Now, that said, we need to make sure that the AI is a good AI, good Grok.
Then he addresses a key aspect of NVIDIA's competitive landscape: Huawei. While NVIDIA is trying to maintain its lead, companies like Huawei are rapidly catching up, particularly with the introduction of systems like Cloud Matrix. Here, Huang does something rare. He acknowledges it and underscores the need for NVIDIA to keep innovating. What's interesting here is how Huang doesn't seem threatened by Huawei's advancements. Instead, he takes the opportunity to underline NVIDIA's strength: its relentless focus on making its technology better, not just on keeping up with competitors. This is where NVIDIA's leadership really shines. Rather than focusing on beating others, they focus on continually evolving their own capabilities. This speaks volumes about the company's confidence in its vision. Huang's ability to acknowledge the competition while simultaneously showcasing NVIDIA's strengths reflects a level of strategic maturity. The AI race is about who can sustain innovation over time, and NVIDIA's focus on scaling its technology and maintaining flexibility gives it the edge.
Remember, people from all over the world want to come to the United States. This is such an extraordinary country with such incredible opportunities. We want the brightest to come here. We don't want others to. We don't want everybody to be able to come here. And there should be rules. But nonetheless, for the ones that really can make a contribution, want to make a difference, we want to make it possible for them to come here and bring their great ideas, bring their great intellect, and help us build a great America. And so I think the administration is all in on that, and I don't think anything that they've said changes that.
Jensen, I surveyed our Bloomberg Technology audience around the world for questions for you, and I think the most common question is understanding who NVIDIA's customers are away from the hyperscalers, but actually many questions about Elon Inc. and whether Tesla and xAI in aggregate might actually be one of the biggest customers you have. You think about not just the data center chips, but the chips specific for Optimus or in the cars. The Omniverse component. Could you speak a little about that?
We do a lot of business with Tesla and xAI. Elon's, as you know, is just an extraordinary engineer, and I love working with him. We've built some amazing computers together. We're going to build many more computers together, and the work that he's doing in Grok, his self-driving car. His Optimus. These are all, every single one of them, world-class. Every single one of them revolutionary. Every single one of them are going to be gigantic opportunities. And we're delighted. I'm delighted to be working with him on that. And so I think the Optimus opportunity is just right around the corner. It's very likely that human robots are going to be robots that we can deploy into the world relatively easily. And this is the first robot that really has a chance to achieve the high volume and technology scale necessary to advance technology. And so I think this is likely to be the next multi-trillion-dollar industry. I'm very excited for him.
Jensen, let's end by talking about Europe. You alluded to a trip you're taking next week. It sounds as if the infrastructure build-out in Europe is coming. Where will you be visiting and who will you be speaking with?
Well, I'm going to leave the who as a surprise for all of you, but I'll be seeing lots of heads of states, and I'll be in France and UK and Germany and Belgium, and I think that it's very clear now that every country recognizes that artificial intelligence, like electricity, like internet, like communications, is part of a national infrastructure. No society could do without intelligence, as you know, and there's an awakening that every country has to take some initiative to ensure that their country and their society has access to artificial intelligence. And so we're really delighted to be able to work with work with the European countries to bring AI infrastructure to them and work with them to build AI factories. There's an umpteen number of AI factory projects in discussion and development, and so I'm really excited to make this trip. We're going to be all over Europe.
And the thing that I think is most important for AI safety, at least my biological neural net tells me the most important thing for AI is to be maximally truth-seeking. So this is a very fundamental. But you can think of AI as this super genius child that ultimately will outsmart you, but you can still you can instill the right values and encourage it to be sort of truthful, honorable, good things like the values you want to instill in a child that would ultimately grow up to be incredibly powerful. So this is really, I'd say, when we say tools, these are still primitive tools, not the kind of tools that serious commercial companies use. But we will provide it with those tools, and I think it will be able to solve with those tools real-world technology problems. In fact, I'm certain of it. It's just a question of how long it takes.
Yes, exactly.
So is it just compute all you need, Tony?
Sorry?
Is it just compute all you need at this point?
Well, you need compute plus the right tools, and then ultimately to be able to interact with the physical world.
Yes.
And then, we'll effectively have an economy that is, ultimately an economy that is thousands of times bigger than our current economy, or maybe millions of times. If you think of civilization as percentage completion of the Kardashev scale, where Kardashev 1 is using all the energy output of a planet, and Kardashev 2 is using all the energy output of a sun, and 3 is all the energy output of a galaxy. We're only, in my opinion, probably like closer to 1% of Kardashev 1 than we are to 10%. So like maybe a point or 1 or 2% of Kardashev 1. So we will get to most of the way, like 80-90% Kardashev 1, and then hopefully, if civilization doesn't self-annihilate, and then Kardashev 2, like it's the actual notion of a human economy, assuming civilization continues to progress, will seem very quaint in retrospect. It will seem like sort of cavemen throwing sticks into a fire level of economy compared to what the future will hold. It's very exciting. I've been at times kind of worried about is this seems like it's somewhat unnerving to have intelligence created that is far greater than our own. And will this be bad or good for humanity? It's like I think it'll be good. Most likely it'll be good. But I somewhat reconciled myself to the fact that even if it wasn't going to be good, I'd at least like to be alive to see it happen. So
actually, one I think one technical problem that we still need to solve, besides just compute, is how do we unblock the data bottleneck? Because when we try to scale up the RL, in this case, we did invent a lot of new techniques, innovations, to allow us to figure out how to find a lot of challenging RL problems to work on. It's not just the problem itself needs to be challenging, but also it needs to be, you also need to have like a reliable signal to tell the model, you did it wrong, you did it right. This is the sort of the principle of reinforcement learning. And as the models get smarter and smarter, the number of cool problems or challenging problems will be less and less.
Yeah.
So it's going to be a new type of challenge that we need to surpass besides just compute.
Yeah, we actually are running out of actual test questions to ask. So there's like even questions that are ridiculously hard, if not essentially impossible for humans, that are written down questions are swiftly becoming trivial for AI.
Then comes the most intriguing part: Tesla and xAI. Huang doesn't just mention Elon Musk as a business partner, he speaks about him with genuine admiration. For Huang, working with Musk is about creating groundbreaking technologies that could change the world. The Optimus robot, Grok, and self-driving cars are harbingers of the future. Huang's excitement about these ventures speaks to a bigger narrative that's unfolding right before us. AI is about machines becoming integral parts of our lives. This is where we see NVIDIA's role in the future of AI take shape. It's about the vision of a world where human-like AI systems exist alongside us. Musk's ambitions for Grok and Optimus are world-changing, and Huang is fully on board. seeing these innovations as the cornerstone of future AI-driven industries. What's particularly exciting here is Huang's take on the potential scale of these technologies. He talks about the possibility of human robots being deployed at scale, something that hasn't been possible until now. The notion that AI robots could one day become a multi-trillion-dollar industry sounds far-fetched, but Huang's confidence suggests otherwise. We've seen this narrative before. Revolutionary technologies often seem out of reach until someone, like Musk or Huang, figures out how to make them a reality. As AI continues to shape the future, NVIDIA is poised to lead the charge with revolutionary technologies like Grok and self-driving cars. The journey is just beginning, and the potential is massive. If you found this breakdown insightful, don't forget to like, share, and drop a comment. Subscribe for more in-depth analyses and exclusive content on the future of AI and tech. See you in the next one. What is GPT-5? That's the question a lot of people are asking right now. And on the surface, it sounds like the next version of ChatGPT. But once you start digging in, it becomes clear. GPT-5 is more than a simple upgrade. This model is being built to do things we've never seen from AI before. It's designed to reason through complex problems, follow conversations across massive amounts of information, and even adapt to how you like to think and communicate. One of the most talked about improvements is its ability to think more clearly. That might sound abstract, but it really matters. GPT-4 gave us quick answers. GPT-5 is being trained to work through problems step by step, like a really smart person thinking out loud, showing their process as they go. That kind of progress could make it way more helpful in fields like medicine, engineering, law, and science. And then there's memory, or what's technically called context. GPT-5 might be able to process and remember hours of conversation, entire books, long meetings, and keep track of every important detail. That means instead of starting from scratch every time, it can follow your thought process, stay consistent, and build on what it's already seen. What makes this even more powerful is the move toward multimodality. GPT-5 isn't just learning to read and write, it's being trained to understand images, maybe even audio and video. Imagine asking it to explain a photo, describe what's happening in a video, or help design something visual. All inside the same conversation. But there's something else going on too, and this part might be the most personal. GPT-5 is being designed to learn about you, your preferences, how you like to be helped, what you care about. Not in a one-size-fits-all way, but in a way that adjusts over time. So every interaction feels more natural, more useful, and more relevant. It's easy to focus on the features, the speed, the tools, the improvements, but the real story is what this means for everyday life. Whether it's helping a student learn faster, helping a doctor see something they missed, or helping someone solve a problem they couldn't tackle on their own, GPT-5 pushes us closer to AI that's not just capable. It's part of how we work and live. In this video, I'm going to walk you through what's coming, how it works, and what it could mean for the future of intelligence, both human and machine.
What people want to know is not where is this one magic moment of we finished. But given that what looks like is going to happen is that the models are just going to get smarter and more capable and smarter and more capable and smarter and more capable on this long exponential. Different people will call it AGI at different points, but we all agree it's going to go way, way past that.
I don't think I'm going to be smarter than GPT-5, and I don't feel sad about it because I think it just means that we'll be able to use it to do incredible things. And we want more science to get done.
Okay, I've been following AI for a while now, and I thought I had a handle on how fast things were moving. But after hearing the latest details about GPT-5, I'm honestly not sure any of us are ready for what's coming. From everything we're hearing, GPT-5 is going to feel like we've jumped several years ahead overnight. I'm talking about huge leaps in reasoning, memory, speed, and personalization, to the point where using AI might actually start to feel like talking to someone who knows you and thinks better than you in some cases. One of the most exciting, and maybe a little terrifying parts, is how much better it's expected to be at reasoning. Right now, GPT-4 can give smart answers, but it's inconsistent. Sometimes it nails it, sometimes it fumbles, GPT-5 is being built to fix that. Sam Altman even said in a recent conversation with Bill Gates that they're working on making the AI think more like a really intelligent person, not just faster, smarter, more thoughtful, more reliable. That alone changes everything. And then there's the memory, or what's called the context window. GPT-4. Turbo can remember a ton already, but GPT-5 might double that or more. We're talking about it being able to read, understand, and respond to entire books, long videos, or huge blocks of code without losing track of what's happening. That's like giving the AI a photographic memory, and it never forgets a single detail. Imagine what that could do in a legal office, in film analysis, in coding, or even customer service. What really caught my attention, though, is the push toward personalization. This is where things get real. GPT-5 is supposed to remember your preferences, how you like information, what topics interest you, even your sense of humor. That means every interaction starts to feel more like you're talking to someone who actually knows you. That's not just convenient. It's the kind of thing that builds trust between humans and machines. And if it gets that right, it's a huge step forward. Oh, and it's not stopping at text. GPT-5 is expected to improve dramatically at understanding images, audio, and maybe even video. This thing is becoming multimodal. So now we're talking about an AI that can look at a picture, describe it, write a story about it, generate a new image based on it, and even answer follow-up questions, all in one session. That blows the door wide open on how we use AI at work, at school, and at home. I know it's easy to tune this stuff out when it sounds like science fiction, but this is very real, and it's coming fast. Whether we're ready for it or not, GPT-5 is going to change how we live, work, and think. In this video, I'll walk you through exactly what makes GPT-5 such a leap forward, the features you need to understand, and why I think this release might be one of the biggest technology moments of the decade.
Yeah, we're extremely excited for this. We've been working on it for a long time. The GPT series of models was amazing at sort of system one type thinking, for lack of a more nuanced word. But we knew what we really wanted was systems that could reason. And there's so much value if you can have AI that can reason through more complex problems. You saw a glimpse of that with the GPT-4 models, but O1 really is the first system that can do pretty advanced reasoning. If you give it a difficult programming challenge or a difficult math problem, a difficult science thing you need help with, you can really get pretty extraordinary results. And we believe this is going to unlock, over time, this will look as significant as the GPT series and unlock a huge set of new, very, very valuable use cases. Think of this as like we're at the GPT-2 stage of these new kind of reasoning models. And you will see it over the coming years go up to the GPT-4 equivalent. But even in the coming months, you'll see it get a lot better as we move from O1 preview to O1, which we shared some metrics for in our launch blog post. It's a very significant step forward. And I think one of the many fun things about these moments of new paradigms is that the improvement curve is really steep. Things that the models just can't solve right now, in a few months they'll be able to solve, a few months after that, be able to solve even more. Importantly, I think we're going to see a whole new set of ways to use these models. When we had GPT 3.5, it was in the API for a while, and then it was really the ChatGPT moment that made people use it a lot. And even then, it took people a while to figure out how to use ChatGPT, and it took us a while to build all the other features and add the things that people wanted. So I think we're that early with O1. There will be totally new ways to use it that are not just a chat interface. It'll take us a while to build those and other people a while to build those. It'll also take users a while to figure out how to use it. And this is pretty different than the GPT models. We have these 5 levels of AI we talk about. The first was chatbots. The second, which we've just reached now, is reasoners. The third is agents. The fourth is sort of innovators, the ability to figure out new scientific information. And the fifth is full organizations. So this move from 1 to 2 took a while, but I think one of the most exciting things about 2 is that it enables level 3 relatively quickly after. and the agentic experiences that we expect this technology to eventually enable, I think will be quite impactful. Yeah, one of the things I believe is when you sit down in a meeting where you're talking about potential major partnership, you can kind of feel in the first few minutes if you really want to do it or not. And I very much felt that sitting down with you. I thought the sort of shared belief in what this new technology can do for customers, for people, and kind of just having, better experiences, better lives. The spirit of T-Mobile as an innovative, experimental company, excited to jump in with us and figure it out together. That was great. The specific use cases that we talked about really improving the sort of customer experience, and sort of what this can mean for totally reimagining how customer support works. It was in your office up in Washington, and I was just like, immediately I remember leaving and being like, we're going to do this. I'm really excited. Like, let's go. We'll just throw our best people at it.
When it comes to Tesla's impressive growth, it's not just about observing from the sidelines. For Tesla bulls and those with a keen eye for uncovering the next stock market gem, Seeking Alpha is your one-stop shop, offering the latest on Tesla, Tesla stock price targets, Tesla innovation, and everything Elon Musk. Clicking on the affiliate links in the description and making a purchase may earn our channel a commission.
One of the many things that we're most excited about, excited about for this new generation of models, is what we can do for personalization for an individual user or customer, and also what we can do for integration, where these models will be able to look at a huge amount of data and use a huge amount of tools and access a huge amount of systems and deliver these hopefully fairly magical experiences. And so as we think about what's possible with IntentCX and this personalization integration coming together, we can dream out pretty far about what it's going to be like for a customer and the next best action. And we can even think further out to things we haven't focused on as much. But I was just watching backstage as you talked about all the amazing networking work, the network work that you're doing, and what I can imagine these models doing there. Yeah, I think this will be one of these things where no one ever wants to go back to the old way. No customer ever wants the old thing again. This is just going to be such a better experience. I think that should be a great fit for what these models can do. And as you mentioned, you have so much data. And I think these models are just so good at making sense of lots of data. So I think one thing that is not well understood by OpenAI is that we don't train our models on API customer data. So like that is your data, other customers' data, that's their data. We can do custom models for you with that data, or we can do, you can do like in-context learning and not even train the model more on the data. But it's not, this is not data that's like improving the base OpenAI models ever. First of all, thank you for saying that. It's a very nice compliment. We build on a gigantic amount of work that has come before us. And, the field of AI is an old field that people have been contributing really brilliant ideas to for a long time. And more than that, if you think about all of the work that had to happen throughout human history to discover semiconductors and build chips and networks and these massive data centers, we're just doing our one little bit on the very top of that. But we try to do it as well as we can, and we try to have a very focused research program. I think one of the mistakes that other research programs make is they don't have enough conviction and a concentration. It's very easy to copy something once it works. So I think the two ways you can succeed are, say, we're going to be a great fast follower, and we're going to just copy whatever OpenAI does or whatever somebody else does that works. And I don't mean that as negative as it came across, because I think there are a lot of companies that just wait to see what works and then do a very good job of polish and execution. But if you're trying to move the frontier, that's very difficult, and conviction and focus, I think, across a lot of people in a very complex environment, that's the best way forward. And so that's what we try to do. We say, okay, we really believe in deep learning. That's our bet. We really believe in a path from where we are to AGI and beyond, but we're willing to get corrected based off of things we learn along the way. And we're going to keep trying to do the next thing in front of us with as much firepower as we can. and trust that over time that will compound. And that's really worked for us. And so that's our simple approach. Yeah, so first of all, it's one of our most important partnerships, but we hope it inspires a lot of other people to see like really what you can do for customers with AI. Like I think this will be just a tremendous new landmark step forward. Healthcare is an area, as you mentioned, where I would expect greatness. I think most of the world, unfortunately, does not get access to great healthcare, and what these models can do for that. I'm really excited to see someone go build the best imaginable AI medical advisor and make that broadly available. I think that'll be a big step forward. Education's another area where we're seeing great stuff happen already today. Watching what people have done. I think O1 has only been out for like 5 days or something, 6 days maybe. Watching what people have been doing with it is really remarkable. And what people used to do with GPT-4 also was pretty good. But if you imagine every student getting personalized tutoring best for them, along with the rest of their educational experience, I think that can be huge. An area that I am extremely personally excited for, that I think is still in the future, but we can now see glimpses of it, is AI helping us accelerate scientific discovery. I believe that most of the real sustainable economic growth in the world, life getting better for all of us, that comes very largely from scientific progress and technological progress. And if AI can accelerate that, if it can help us invent new stuff, cure diseases, come up with better energy sources, whatever, that'll be a huge win.
I mean, there is wide uncertainty, and there's also different definitions of what superintelligence is. Yes, 2 years ago, we thought we were on a pretty steep curve. I mean, we started OpenAI because we thought this was possible and maybe not that far away. And it has gone well, but we hoped it was going to go well. Like we believed in deep learning as this unbelievable new discovery of humanity, and we thought it could go here, and we had a duty to get it here and to make it go well and to broadly share the benefits. But yeah, we did think we could get here, and we still believe we can get here. It's not for sure. There's a ton of hard work, a ton of research and engineering still to do, but I think it's possible. And I think it's possible not super far in the future. I expect that in 2025, we will have systems that people look at, even people who are skeptical of current progress, and say, wow, I did not expect that. That does change what.
But do you know who else shares in pro-Tesla optimism? That would be today's sponsor, Seeking Alpha. Seeking Alpha is the best pro-Tesla news source on the internet. Click the affiliate link in the description below to get the latest Tesla offering, price targets, innovation, and everything Elon Musk. Link in the description for a very special offer.
Agents are the thing everyone is talking about, I think for good reason. This idea that you can give an AI system a pretty complicated task, like a kind of task you'd give to a very smart human that takes a while to go off and do and use a bunch of tools and create something of value. That's the kind of thing I'd expect next year. And that's like a huge deal. We talk about that like, oh, this thing is going to happen. But that's like, if that works as well as we hope it does, that can really transform things. I've always been struck by how much people love to speculate on, is there a wall? Is scaling going to keep going? And rather than just look at the curve of progress and say, maybe I shouldn't bet against an exponential like that. In any case, we have a bunch of new great stuff. So we're doing this kind of fun thing for the holidays. We're doing 12 days of OpenAI starting tomorrow. But we're going to we'll either launch something or do a demo every day for the next 12 weekdays. And without saying too much about the thing for tomorrow, it is continued progress.
The RLHF, the post-training step, the little wrapper of things that, from a compute perspective, little wrapper of things that we do on top of the base model, even though it's a huge amount of work. Mm-hmm. That's really important, to say nothing of the product that we build around it. In some sense, we did have to do two things. We had to invent the underlying technology, and then we had to figure out how to make it into a product people would love, which is not just about the actual product work itself, but this whole other step of how you align it and make it useful. That was a known difficult thing. We knew we were going to have to scale it up. We had to go do two things that had never been done before, that were both I would say quite significant achievements. And then a lot of things like scaling it up that other companies have had to do before. People like most people don't need all the way to 128 most of the time, although, if we dream into the distant future, we'll have way distant future, we'll have context length of several billion, you will feed in all of your information, all of your history over time, and it'll just get to know you better and better, and that'll be great. For now, the way people use these models, they're not doing that. And, people sometimes post in a paper or, a significant fraction of a code repository or whatever. But most usage of the models is not using the long context most of the time. I saw this internet clip once. I'm going to get the numbers wrong, but it was like Bill Gates talking about the amount of memory on some early computer. Maybe it was 64K, maybe 640K, something like that. And most of it was used for the screen buffer. And he just couldn't seem genuine as couldn't imagine that the world would eventually need gigabytes of memory in a computer or terabytes of memory in a computer. Or you always do just need to follow the exponential of technology, and we're going to we will find out how to use better technology. So I can't really imagine what it's like right now for context links to go out to the billions someday. And they might not literally go there, but effectively it'll feel like that. But I know we'll use it and really not want to go back once we have it. The thing that I find most interesting is not any particular use case, that we can talk about those, but it's people who kind of this is mostly younger people, but people who use it as their default start for any kind of knowledge work task.
Yeah.
And it's the fact that it can do a lot of things reasonably well. You can use GPT-V, you can use it to help you write code, you can use it to help you do search, you can use it to edit a paper. The most interesting thing to me is the people who just use it as the start of their workflow. I think it's going to get a lot better with upcoming versions, but we'll have to continue to work on it, and we're not going to have it all solved this year. I'm of two minds about that. I think people are much more sophisticated users of technology than we often give them credit for. And people seem to really understand that GPT, any of these models, hallucinate some of the time, and if it's mission critical, you got to check it.
So I knew that I wanted to do something with AI, but you got to rewind to the mindset of 2015. It was clear that there was something interesting happening with deep learning, and it was clear that it got better with more scale, and nothing else was clear. We didn't know what we were going to do. We started the OpenAI, and the very first day, I remember so clearly, we sat around the room looking at each other one morning being okay, what now? We really had no idea what to do. We thought, let's do some research, let's come up with some papers, let's think of some ideas. Not only was any product or revenue stream super far in our future, the idea of language models was super far in our future. The idea that we would ever actually be able to make something people would want to use and was not just a paper that other people would implement was super far in our future. So if you start a for-profit, you have to theoretically have some idea of what you're going to do to be a money-making entity someday. And our initial conception of OpenAI was, let's just be a research lab and see if we can get anything at all to work. And it took a long time to get anything at all to work. And then the stuff that we did get to work for a while has, other than good research that sort of pointed us to the next step on the path, has nothing to do with what we did now. So, we made something that could play Dota 2. That's very hard to build a business around. We made a robot hand that barely could do a Rubik's Cube. But eventually, after a lot of stumbling in the dark, we did figure out something that turned out to be a product and a real business. We also found that the direction of research that you don't get to choose where the science goes. You kind of just have to follow it. And where we had to follow it turned out to require gigantic amounts of resources to keep pushing progress. And so we needed a business model to feed that too.
Well, there's all these different evals that we could talk about. And
what's an eval?
Oh, how we measure a model as we're training it, after we've trained it, and say how good is this at some set of tasks.
And also, just on a small tangent, thank you for sort of opening sourcing the evaluation process.
Yeah. I think that'll be really helpful.
Are you using OpenAI? If not, too bad, because a lot of people are. Millions of users are tapping into artificial intelligence to help with research, automate tasks, and build new tools. Now, the CEO of OpenAI, Sam Altman, is talking about something that goes way beyond chatbots and coding assistants. He's talking about AI agents, autonomous systems that can make decisions, take action, and learn on their own. Let's break down what he said, why it matters, and how these agents could quietly flip the entire market upside down.
High level, what is GPT-4? How does it work, and what to you is most amazing about it?
It's a system that we'll look back at and say was a very early AI. And it's slow, it's buggy, it doesn't do a lot of things very well, but neither did the very earliest computers. And they still pointed a path to something that was going to be really important in our lives, even though it took a few decades to evolve.
Do you think this is a pivotal moment? Like, out of all the versions of GPT 50 years from now, when they look back at an early system that was really kind of a leap, in a Wikipedia page about the history of artificial intelligence, which of the GPTs would they put?
That is a good question. I sort of think of progress as this continual exponential. It's not like we could say here was the moment where AI went from not happening to happening. And I'd have a very hard time pinpointing a single thing. I think it's this very continual curve. Will the history books write about GPT 1 or 2 or 3 or 4 or 7? That's for them to decide. I don't really know. I think if I had to pick some moment from what we've seen so far, I'd sort of pick ChatGPT. It wasn't the underlying model that mattered. It was the usability of it, both the RLHF and the interface to it.
What is ChatGPT? What is RLHF? Reinforcement learning with human feedback. What was that little magic ingredient to the dish that made it so much more delicious?
So we trained these models on a lot of text data, and in that process, they learn the underlying something about the underlying representations of what's in here or in there, and they can do amazing things. But when you first play with that base model that we call it, after you finish training, it can do very well on evals. It can pass tests. It can do a lot of, there's knowledge in there, but it's not very useful. Or at least it's not easy to use, let's say. And RLHF is how we take some human feedback. The simplest version of this is show two outputs, ask which one is better than the other, which one the human raters prefer, and then feed that back into the model with reinforcement learning. And that process works remarkably well with, in my opinion, remarkably little data to make the model more useful. So RLHF is how we align the model to what humans want it to do. Maybe just because it's much easier to use. It's much easier to get what you want. You get it right more often the first time, and ease of use matters a lot, even if the base capability was there before.
And like a feeling like it understood the question you were asking, or like it feels like you're kind of on the same page.
It's trying to help you.
It's the feeling of alignment.
Yes.
I mean, that could be a more technical term for it. And you're saying that not much data is required for that. Not much human supervision is required for that.
To be fair, we understand the science of this part at a much earlier stage than we do the science of creating these large pre-trained models in the first place. But yes, less data, much less data.
That's so interesting. The science of human guidance. That's a very interesting science. And it's going to be a very important science to understand how to make it usable, how to make it wise, how to make it ethical, how to make it aligned in terms of all the kind of stuff we think about. And it matters which are the humans and what is the process of incorporating that human feedback, and what are you asking the humans? Is it two things? Are you asking them to rank things? What aspects are you asking the humans to focus in on? It's really fascinating. But what is the data set it's trained on? Can you kind of loosely speak to the enormity of this data set?
The pre-training data set?
The pre-training data set, I apologize.
We spend a huge amount of effort pulling that together from many different sources. There are open source databases of information. We get stuff via partnerships. There's things on the internet. It's a lot of our work is building a great data set. Yeah, I think one thing that is not that well understood about creation of this final product, like what it takes to make GPT-4, the version of it we actually ship out and that you get to use inside of ChatGPT, the number of pieces that have to all come together, and then we have to figure out either new ideas or just execute existing ideas really well at every stage of this pipeline. There's quite a lot that goes into it.
So there's a lot of problem solving. Like you've already said for GPT-4 in the blog post and in general, there's already kind of a maturity that's happening on some of these steps, like being able to predict before doing the full training of how the model will behave.
Isn't that so remarkable, by the way, that there's like, there's like a law of science that lets you predict for these inputs, here's what's going to come out the other end. Like, here's the level of intelligence you can expect.
Is it close to a science, or is it still... because you said the word law and science, which are very ambitious terms.
Close to, I said.
Close to, right? Let's be accurate, yes.
I'll say it's way more scientific than I ever would have dared to imagine.
So you can really know the peculiar characteristics of the fully trained system from just a little bit of training.
Like any new branch of science, we're going to discover new things that don't fit the data and have to come up with better explanations. And that is the ongoing process of discovery in science.
So
but with what we know now,
GPT-5 coming
even what we
out
had in that GPT-4 blog post,
That's the honest answer.
I think we should all just be in awe of how amazing it is that we can even predict
twice if it's this year.
Sam Altman just gave us a peek behind the curtain. And if you're paying attention, what he said should give you chills.
An amazing model this year.
GPT-4, he admits, is still kind of clunky.
So that goes to the question of what...
But that's exactly the point.
What's the way we release this thing?
This is the early version.
We'll release...
And even now, it's capable of passing medical exams, writing code,
many different
and
things,
mimicking human reasoning in ways that seemed impossible just a few years ago.
Before we talk about like a GPT-5 like model called that or not called that, or a little bit worse or a little bit better than what you'd expect from a GPT-5, I think we have a lot of other important things to release first.
I don't know what to expect from GPT-5. You're making me nervous and excited. What are some of the biggest challenges and bottlenecks to overcome for whatever it ends up being called, but let's call it GPT-5? Just interesting to ask. Is it on the compute side? Is it on the technical side?
Always all of these. I was, what's the one big unlock? Is it a bigger computer? Is it like a new secret? Is it something else? It's all of these things together. Like the thing that OpenAI, I think, does really well.
There's been speculation that GPT-5 might not even exist, but now we know that's just not true. Sam Altman, the CEO of OpenAI, dropped a detailed roadmap on X that confirms GPT-5 is not only real, but it's coming soon. And this reveal has the tech world buzzing, especially Google. Altman said they're scrapping the confusing model picker and replacing it with a unified system that just works. GPT-5 will combine everything OpenAI's built: voice, canvas, deep research, tools, and use it all intelligently, depending on what you're doing. Free users will even get unlimited access to GPT-5 at a base level, while paid plans unlock higher intelligence tiers. That's a big deal. Why does this have Google panicking? Because OpenAI isn't just improving its tech, it's simplifying it in a way that's going to be hard to compete with. Meanwhile, models like DeepSeek are already showing up with strong performance at a fraction of the cost. OpenAI needed to strike back, and this roadmap shows they're doing it.
This is actually an original Ilya quote that I'm going to butcher, but it's something like, we multiply 200 medium-sized things together into one giant thing.
So there's this distributed constant innovation happening.
Yeah.
So even on the technical side,
especially on the technical side.
So even detailed approaches, detailed aspects of every. How does that work with different disparate teams and so on? How do the medium-sized things become one whole giant transformer? How does this?
There's a few people who have to think about putting the whole thing together, but a lot of people try to keep most of the picture in their head.
Oh, like the individual teams, individual contributors try to keep
at a high level. Yeah, you don't know exactly how every piece works, of course, but one thing I generally believe is that it's sometimes useful to zoom out and look at the entire map. And I think this is true for a technical problem. I think this is true for innovating in business. But things come together in surprising ways, and having an understanding of that whole picture, even if most of the time you're operating in the weeds in one area, pays off with surprising insights. In fact, one of the things that I used to have, and I think was super valuable, was I used to have a good map of all of the frontier, or most of the frontiers in the tech industry. And I could sometimes see these connections or new things that were possible that if I were only, deep in one area, I wouldn't be able to like have the idea for, because I wouldn't have all the data. And I don't really have that much anymore. I'm like super deep now. But I know that it's a valuable thing.
So yeah, when is GPT-5 actually coming? Sam Altman's answer was, I don't know, but let's be real. We do know something big is on the way. He didn't deny GPT-5. In fact, the way he danced around the name kind of confirms it for me. He even said, we'll release an amazing model this year, and honestly, that sounds like GPT-5 to me. Or at least something even better. What's interesting is how he described the process. It's not just one breakthrough. It's hundreds of medium-sized innovations all coming together. That's wild. OpenAI isn't just waiting for one magic idea. They're constantly stacking improvements, testing, refining, and then stitching it all together. That approach feels way more powerful long-term than what most companies are doing. I really get the sense that GPT-5, or whatever they end up calling it, is close. And what excites me is that this isn't just an upgrade in power, it's a shift in how we interact with AI. If they actually pull off this unified intuitive system, it's going to completely change how we use these tools day to day.
You stop here?
Okay, sure. I mean, I think the whole industry is waiting with bated breath for the release of GPT-5. I guess it's been reported that it's launching sometime this summer, but that's a pretty big window. Can you narrow that down? I guess where are you in the release of GPT-5?
We take our time on releases of major new models, and I don't think I think it will be great when we do it, and I think we'll be thoughtful about how we do it. Like we may release it in a different way than we've released previous models. Also, I don't even know if we'll call it GPT-5. What I will say is, a lot of people have noticed how much better GPT-4 has gotten since we've released it, and particularly over the last few months. Now we are finding incredible efficiency gains, and that's really important. One of the cool thing that we launched today is obviously the voice mode, but maybe the most important thing is we were able to make this so efficient that we're able to serve it to free users. Like best model in the world by a good amount. If you will look at that little thing, served to like anybody who wants to download ChatGPT for free. And it was a remarkable efficiency gain over GPT-4 and GPT-4 Turbo, and we have a lot more to gain there.
If we're going to compare GPT-4 to GPT-5, because you're at the cusp of this, you're actually seeing it at the forefront. What is the difference? Like, if I'm excited about GPT-5, what should I be excited about?
It's going to be smarter. There are all of these other things, we can talk about. It'll be better at these kind of tasks. It'll be multimodal. It'll be faster. Who knows what. But the thing that I think really matters is it's going to be smarter. And this is a bigger deal than it sounds, right? Because what makes these models so magical is that they're general. And so if it's a little bit better, if it's a little bit smarter, that means it's a little bit better at everything. And the thing that I think is most exciting is it's not like this model is going to get a little better at this task and not really better at these, or, it's not that. It's because we're going to make the model smarter. It's going to be better at everything across the board.
Google just dropped a surprise Gemini update that turns web app coding into a one-prompt magic trick, weeks before I/O. Apple's secretly striking a deal to stuff that same AI into iPhones. Meanwhile, OpenAI is tearing up its corporate plans, slashing Microsoft's cut, and casually spending $3 billion to buy a coding startup. Google basically shouted surprise and pushed an early preview of Gemini 2.5 Pro, the I/O edition, out the door a couple of weeks ahead of schedule. People at Google's AI studio are already calling it the Web Dev Arena Champ because it jumped 147 ELO points over the previous build. That ELO thing is basically a popularity contest judged by humans on how nice and functional your generated web apps look, and the new score plants Gemini on top of the leaderboard. It's also flexing an 84.8% on the video MME benchmark, which measures how well a model actually understands what's happening in video clips instead of just pretending.
while Sam Altman is out here playing it cool, you can tell Google is feeling the pressure. They've been moving fast, releasing Gemini 2.5 Pro right after GPT 4.5 came out. And to be fair, Gemini 2.5 Pro is impressive. It scored higher than GPT 4.5 in several reasoning benchmarks, math, coding, even in humanities' last exam, where it basically tripled GPT 4.5's score. It's free to use too, which makes it super accessible for businesses and devs. But here's the thing. I don't think this was just a regular product launch. It feels like a defensive move. They had to get something out before GPT-5 dropped. Because if OpenAI rolls out what Sam hinted at, this all-in-one, deeply integrated, intuitive system, then Gemini's moment might be short-lived. My gut says Google knows that. That's why they're cranking out these updates. But OpenAI's been stacking wins quietly, and when GPT-5 lands, whatever they end up calling it, it could push the whole industry forward in a way Gemini's still chasing.
With ChatGPT 4.1 just released and GPT-5 supposedly dropping in a couple of months, a lot of people are asking, which platform should I focus on? Should you jump to Gemini or stick with ChatGPT and then switch to GPT-5 when it launches? Now, GPT-5 isn't out yet, but we have plenty of hints about what it will be like. The main theme seems to be simplifying the user experience. Even the naming system is supposed to get an overhaul. No more endless model selectors. Sam Altman hinted on X, how about we fix our model naming by this summer? And the only real way to do that is to unite everything into a single model. Over time, OpenAI ended up with a bunch of different AI versions. Look at GPT-4. You've got different modes, different versions for coding or writing, plus experimental models like O3 or O1 for reasoning. It gets confusing. The plan for GPT-5 is to bundle all these improvements into one super-powered model. In Sam Altman's words, GPT-5 will integrate a lot of our technology, including O3, instead of rolling them out as standalone models. Every feature, from logical reasoning to image creation, should get a major upgrade.
So we don't know yet. We're optimistic, but we still have a lot of work to do on it. But I expect it to be a significant leap forward. A lot of the things that GPT-4 gets wrong, can't do much in the way of reasoning, sometimes just sort of totally goes off the rails and makes a dumb mistake, even like a 6-year-old would never make. I expect it to be much, much better in those ways and to be able to be used for a much wider variety of more helpful tasks.
GPT-5 is coming in the next weeks/months, and here's what you can expect from it. What will be referred to as GPT-5 will be a system that will integrate all of this tech, including their state-of-the-art O3 thinking model, into one focused experience where ChatGPT will figure out if you need a thinking model or not, if you need one application or another one by itself. This is not going to be a model router that will be deciding if you're going to be picking GPT-4o or O1 or O1 Pro. No, it's going to be a unified experience. Interesting. And when asked about the estimated time of arrival on these, he said weeks/months, which in my books means before summer, essentially. That'd be my guess, maybe even sometimes before April. Who knows?
Yeah, well, we're very excited about GPT-5. There are teams working on it as we speak, and I think it's going to be a fantastic new model when we get there. But in general, this is the year that ChatGPT goes from answering questions for you to doing things for you in the real world. So, by that I mean we launched a product earlier this year called Operator that can browse the web like a human and do things for you. When I think about the time I spend on the web, I bet 30 or 40% of the time that I'm browsing the web, it's not because I want to be doing what I'm doing, it's because I have to get something done, and there's some series of pages and forms I have to fill out and other things. I would love an AI to do that for me. I would absolutely love for an AI to fill out those forms for me so that I can concentrate on, either getting more work done or spending more time with my family. And this is the year when AI begins to do more things like that for you. And I'm very excited about that. It comes because of the advances that we're making with these reasoning models that are getting smarter and safer. And it comes with integrations into the sites that you know and use every day so that our models can understand them and can take action on your behalf.
And now we've got Kevin Weil confirming what we've all been expecting. GPT-5 is coming in 2025. But what really caught my attention wasn't just the confirmation. It was how he described what GPT-5 will actually do. This isn't just about answering questions anymore. This is the year ChatGPT starts doing things for you, like actually completing real-world tasks, browsing the web, filling out forms, booking stuff. clicking buttons, the boring stuff we waste time on every day. He mentioned their new product, Operator, which already knows how to browse like a human. That's wild. If GPT-5 builds on that, imagine giving your AI a task and just watching it get done while you focus on something else. That's not a small upgrade. That's a full-on shift in how we use the internet. Now compare that to Gemini 2.5 Pro. Yes, it's strong in reasoning, math, and coding benchmarks. And yeah, it's free. But Gemini still feels like a tool you use, not a system that acts for you. GPT-5, on the other hand, is heading toward true AI agents, systems that handle tasks, take initiative, and help us reclaim our time.
Gemini really does have all the same features ChatGPT offers, just built right in. Unlike simpler chatbots, Gemini 2.5 is a thinking model, meaning it goes through its own internal reasoning process before giving you an answer. That makes it great for complex stuff like riddles, tough concepts, or writing clean, correct code. Gemini 2.5 is also natively multimodal, which is just a fancy word of saying it can handle different kinds of input, not just text. You can throw a paragraph at it, or a picture, or even audio, and it will work with all of those. In fact, it's designed to process text, audio, images, and video as input. Compare that to ChatGPT, which still can't do videos at all.
People in college use it as an operating system. But this is going to be a very different world. And if you look at the progress from even before GPT-3, which Toby just mentioned, but GPT-2 in 2019, people tried it and said, this is like a dead-end direction. Scaled it up, GPT-3, people were like, oh, okay. GPT 3.5 was like finally usable. And GPT-4, people are building entire companies around. GPT 5, 6, and 7, I think will continue in future years on this trajectory of really increasing the utility they can provide. And this is like a big new exciting thing to have in the world.
So yeah, between Google trying to hold the line with Gemini and OpenAI quietly building something way more powerful behind the scenes, it really feels like we're on the edge of a major shift. GPT-5 isn't just a model update, it's a step toward AI that can work for us, not just talk to us. And when that drops, it's going to change how we use the internet, how we get things done, and honestly, how we live day to day. If Google's got something big at I.O., they better bring it. Because from everything we're seeing, OpenAI is about to set a whole new standard. Let me know what you think. Are you excited for GPT-5? Do you think Gemini has a shot? Drop your thoughts in the comments. I'll be reading them. And if you enjoyed this breakdown, hit that like button, subscribe for more updates, and I'll see you in the next one.
Let's talk about quantum computing. 1981, particle physicist, quantum physicist Richard Feynman imagined a new type of computer that can simulate nature directly. Simulate nature directly. Because nature is quantum. He called it a quantum computer. 40 years later, the industry has made a fundamental breakthrough.
For years, quantum computing has been a dream, something futuristic, distant, almost mythical. A technology so advanced, it promised to solve problems that even today's most powerful supercomputers can't touch. But this week, NVIDIA's Jensen Huang changed everything. Because what he just revealed isn't science fiction anymore. It's a new kind of computing, one that merges quantum processors and AI supercomputers into a single, unified system. And if he's right, this could reshape the future of artificial intelligence forever. To understand why this matters, let's start with the basics. At the core of every quantum computer are qubits, quantum bits that can exist in multiple states at once. They're powerful, but they're also fragile. Qubits are so sensitive that the slightest noise, heat, or interference can cause them to collapse. In the real world, that means today's quantum machines can only perform a few hundred operations before breaking down. But to solve meaningful problems, like modeling molecules, cracking encryption, or training AI, you need trillions of operations. That's been the wall quantum computing could never break through. Until now. In a stunning announcement, Jensen Huang introduced what NVIDIA calls NVQ-Link, a groundbreaking interconnect architecture that bridges quantum processors directly with NVIDIA GPUs. Think of it as a neural bridge between two worlds, the probabilistic realm of quantum mechanics and the deterministic power of classical computing. This is not about replacing one with the other. It's about fusing them. For the first time, quantum processors can offload their calculations to NVIDIA's GPUs in real time, correcting errors as they happen, something once thought impossible. Let's pause here for a second because this is the kind of detail that sounds technical but has massive implications.
There's an inflection point happening in quantum computing. The number of logical qubits are starting to grow. 40 years later, just last year, a fundamental breakthrough. It is now possible to make one logical qubit. Well, just like Moore's Law would, I could totally expect 10 times more logical qubits every 5 years. One logical qubit. One logical qubit that's coherent, stable, and error-corrected. 100 times more logical qubits every 10 years. Those logical qubits would become better error-corrected, more robust. In the past, now that one logical qubit consists of, could be sometimes tens, sometimes hundreds of physical qubits, all working together.
See, quantum computers don't just fail when they make a mistake. They erase the information entirely. Measuring a qubit collapses it. It's like trying to read a snowflake without melting it. The only solution is quantum error correction, adding extra qubits that entangle with others, allowing you to detect where an error occurred without disturbing the original data. It's brilliant in theory. But it's also so computationally demanding that even the world's fastest supercomputers can't handle it efficiently. That's why Huang's reveal is so important. NVQLink was built precisely to solve that. By connecting quantum chips directly to NVIDIA GPUs, NVQLink allows terabytes of data to move back and forth thousands of times per second. That's enough speed to detect, calculate, and correct quantum errors on the fly, without destroying the fragile state of the system. At the heart of this system is something called Q2Q, NVIDIA's open platform for quantum GPU computing. It lets researchers coordinate both quantum processors and AI supercomputers simultaneously, effectively turning them into one brain. And for the first time, we're looking at a platform where AI and quantum computing can work hand in hand instead of existing in separate silos. To grasp how revolutionary this is, imagine what happens when AI and quantum physics stop being two separate fields and start powering each other. Quantum systems could feed AI models data from realms we can't even simulate today. AI could optimize quantum circuits, correct errors faster, and design entirely new materials or drugs at atomic precision. It's the dawn of accelerated quantum supercomputing, where two once impossible technologies merge into one. And NVIDIA is placing itself right at the center of that revolution. Huang didn't say this outright, but the implications are clear. NVIDIA isn't just the GPU company anymore.
As you know, qubits, these particles are incredibly fragile. Higher performance, more resilient, and of course, will continue to be scalable. They could be unstable very easily. Any observation, any sampling of it, any environmental condition causes it.
About developing new materials, Jim, at the molecular level, perhaps down the road. They do have this partnership with Novo on drug discovery.
And so it takes extraordinarily well-controlled environments and now also a lot of different physical qubits for them to work together.
Look, I've been waiting for that. Recursion was supposed to be 1, 2, and the drug person is excellent. I'm keep hoping that they do some big deals on.
And for us to do error correction on these, what are called auxiliary or syndrome qubits.
Cancer, you're able. I've been listening to a lot of people who claim they have AI, and it's starting to bother me again because they're doing spreadsheets.
For us to error correct them and infer what that logical qubit state is.
Calling it AI. After working with all of the sites that are now saying they're really good at math, they're awful at math.
There are all kinds of different types of quantum computers. Superconducting, photonic, trapped ion, stable atom, all kinds of different ways.
But you're seeing, I did a piece last night that basically said, okay, here we go. IONQ, D-Wave quantum, Rigetti, quantum computing.
To create a quantum computer. We now realize that it's essential for us to connect a quantum computer directly to a GPU supercomputer.
I'm not saying I'm a sage.
No.
I am saying that Jensen is giving the green light to a lot of companies that may mean absolutely nothing, but they have quantum in their name.
So that we could do the error correction, so that we could do the artificial intelligence calibration and control.
I mean, Honeywell's been very honest and said, listen, we're not ready. Right. And IBM does have quantum, and that's one of the reasons why IBM is at an all-time high.
Quantum computer, and so that we could do simulations collectively, working together, the right algorithms running on.
Those are incredible moves. If you were lucky enough to have decided that quantum was where you wanted to be at the beginning of this year, you are very happy, or even last year.
Well, what do you mean
guys?
That?
The GPUs, the right algorithms running on the QPUs, and the two processors, the two computers working side by side.
Well, I mean, I think it's not yet proven, right? We don't know.
But it's younger people who are really cashing in.
And you've made this.
Sit here and tell people to buy Smucker.
You've made this.
This is the future of quantum computing. Let's take a look. There are many ways to build a quantum computer.
This point, right? You've made this point about nuclear and certain crypto assets.
Well, it's very disheartening. I'm disheartened by it.
Well, don't be disheartened.
Why?
Each uses qubits, quantum bits, as its core building block. No matter the method, all qubits, whether superconducting qubits, trapped ions, neutral atoms, or photons, share the same challenge.
What value added do we have? I read the names.
You want to get heartened? Read Sam Altman's blog post from last night. It's entitled "The Gentle Singularity."
They're fragile and extremely sensitive to noise. Today's qubits remain stable for only a few hundred operations.
We had Jensen. I think when you talk about the leaders right now in terms of where the future is, it's Jensen, and a lot of it's Sam Altman.
But solving meaningful problems requires trillions of operations. The answer is quantum error correction. Measuring disturbs a qubit.
They're great friends, and remember, nothing took off.
I took out a few things
until
that
gave Sam the
I took
chips.
out a few things that just struck
Sure,
me in
please
what is
tell me something
in
good.
what
Destroys the information inside it. The trick is to add extra qubits, entangle, so that measuring them gives us enough information to calculate.
It's a letter that I think people should read because it's got a lot of different things in it, but part of it is, of course, talking about the near-term advances that are coming.
Where errors occurred without damaging the qubits we care about. It's brilliant, but needs beyond state-of-the-art conventional compute.
2030s, for example, he writes, intelligence and energy, ideas, and the ability to make ideas happen are going to become wildly abundant.
That's why we built NVQ-Link, a new interconnect architecture that directly connects quantum processors with NVIDIA GPUs.
It's the operating system of the future. They already dominate AI training with their H100 and Blackwell chips. Now, they're positioning themselves as the connective tissue between AI and the next generation of quantum machines. And if NVQ-Link works the way it's designed, NVIDIA will control the very infrastructure that every future quantum and AI system depends on. This isn't just about faster chips. It's about rewriting the foundation of computing itself. Jensen Huang's reveal also challenges one of the biggest misconceptions in tech, that quantum computers will one day replace traditional ones. In reality, as he explained, quantum and classical systems will coexist, complementing each other instead of competing. Classical supercomputers will handle structured data, logic, and precision. Quantum processors will take on the chaotic, probabilistic calculations that classical hardware simply can't. Together, they form what Huang calls a fused platform, a hybrid system capable of tackling humanity's hardest problems, from climate modeling to molecular design, from AI cognition to advanced robotics. And the key to making all of this possible is NVQ-Link. Let's not miss how strategic this move really is. Quantum startups like IBM, Rigetti, and IonQ have been racing to build larger, more stable qubit systems. But NVIDIA isn't competing with them, it's enabling them. By providing the connective platform, NVIDIA becomes indispensable to everyone in the ecosystem. Whether your quantum processor uses trapped ions, photons, or superconducting qubits, you'll need NVQ-Link to make it viable at scale. It's the same playbook NVIDIA used with GPUs 2 decades ago. Build the tools everyone relies on, and you become the center of innovation itself. But this is also about AI supremacy. If quantum systems start accelerating AI training, NVIDIA's lead over competitors like AMD and Intel could become permanent. AI models that once took weeks to train could one day be optimized in hours, powered by quantum acceleration. And in a world where every major corporation and government is racing to dominate AI, that's the kind of advantage that could reshape global power. Still, it's not without risks. Quantum computing is unpredictable. The physics are fragile, the hardware is experimental, and integrating such systems with AI at this scale introduces cybersecurity, stability, and governance questions no one has fully answered yet. Even Jensen Huang admitted this is just the beginning. Quantum error correction is a monumental challenge, and despite NVQ-Link, it's far from solved. But as Huang said during the announcement, this isn't about waiting for perfect technology. It's about building the bridge now, so that when quantum computing finally matures, the infrastructure is already in place. That's classic NVIDIA. Move first, build the ecosystem, and let everyone else catch up later. The company has already transformed gaming, AI, and data centers. Now, it's setting the stage to transform physics itself. Huang's quantum reveal wasn't just about new hardware. It was about a vision, one where AI and quantum computing fuse into a single, accelerated reality. And whether the world is ready or not, NVIDIA is already building it. So what does this mean for the rest of the tech world? For Google, Microsoft, and Amazon, who all have their own quantum divisions, it means NVIDIA is no longer just a supplier. It's now a direct competitor in the race for computing dominance. For researchers, it means new possibilities. Solving molecular equations, modeling materials, or training AIs that can reason beyond current limits. And for everyone else, it means the future of technology might arrive far sooner than anyone expected. Huang's message was simple, but powerful. Quantum computing won't replace classical systems. It will work with them. Fused together, they'll create something faster, smarter, and more powerful than anything we've ever built before. And that's not a distant dream. That's NVIDIA's next product cycle. End. Cinematic outro line. This is the story of Jensen Huang's quantum reveal, and how it may reshape not just the future of AI, but the very definition of computing itself.
Quantum error correction requires reading out information from qubits, calculating where errors occur.
We hear that word a lot, by the way, abundant. These two have been the fundamental limiters on human progress for a long time. With abundant intelligence and energy and good governance,
and sending data back to correct them. NVQ-Link is capable of moving terabytes of data to and from quantum hardware.
We can theoretically have anything else. He goes on to say, if we have to make the first million humanoid robots the old-fashioned way,
the thousands of times every second needed for quantum error correction. At its heart is CUDA-Q.
Girls driving trucks, running factories to build more robots, which can then build more chip fabrication facilities, data centers, and the rate of progress will be quite different.
Our open platform for quantum GPU computing. Using NVQ-Link and CUDA-Q, researchers will be able to do more than just error correction.
And finally, last part I'll take for you guys, and the one I've been focused on, there will be very hard parts, like whole classes of jobs.
They will also be able to orchestrate quantum devices and AI supercomputers to run quantum GPU applications.
Going away. But on the other hand, the world will be getting so much richer so quickly that we'll be able to seriously entertain new policy ideas we never could before.
We won't replace classical systems. They will work together, fused into one accelerated quantum supercomputing platform.
We probably won't adopt a new social contract all at once, but when we look back in a few decades, the gradual changes will have amounted to something big.
This is a physical job. So today we're announcing the NVQ-Link. NVQ-Link.
Well, okay, so nobody's going to have a job, so we're all going to be wandering around looking for some purpose. We're going to have an age of abundance. An age of abundance.
You drive me crazy.
Thank you.
And it's made possible by two things. Of course, this interconnect that does quantum computer control and calibration.
Handmaid's tale, and we need people. And you may think that and we're rounding up people in this country and sending them where God knows where.
Correction as well as connects two computers, the QPU and our GPU supercomputers, to do hybrid simulations.
We don't let anybody in the country. We have a series of jobs now that the only people who really wanted them were people who felt, look, this is how I can get my kid to a college.
Really scalable. It doesn't just do error correction for today's number of few qubits. It does error correction for tomorrow. Essentially scale up these quantum computers from the hundreds of qubits we have today to tens of thousands of qubits, hundreds of thousands of qubits in the future. So I can do control, co-simulation, quantum error correction, and scale into that future. The invention of CUDA-Q, remember, CUDA was designed for GPU, CPU, accelerated computing. Using both processors to use the right tool to do the right job. Now, CUDA-Q has been extended beyond CUDA so that we could support QPU and have the two processors, QPU and the GPU, work and have computation move back and forth within just a few microseconds. The essential latency to be able to cooperate with the quantum computer. Breakthrough adopted by so many different developers. We are announcing today 17 different quantum computer industry companies. And I'm so excited about this. 8 different DOE labs, Berkeley, Brookhaven, Fermi Labs in Chicago. Just about every single DOE lab has engaged us, working with our ecosystem of quantum computer companies, integrate quantum computing into the future of science. I have one more additional announcement to make. Announcing that the Department of Energy is partnering with NVIDIA to build 7 new AI supercomputers to advance our nation's science. I have to have a shout out for Secretary Chris Wright. He has brought so much energy to the DOE, a surge of energy, a surge of passion. Computing is the fundamental instrument of science, and we are going through several platform shifts. On the one hand, we're going to accelerated computing. We're going to AI, so that AI and principled solvers, principled simulation, principled physics simulation is not going to go away. Enhanced, scaled, use surrogate models, AI models, working together. That principled solvers, classical computing, can be enhanced to understand the state of nature using quantum computing. That in the future, we have so much signal, so much data we have to sample from the world, remote sensing is more important than ever. These laboratories are impossible to experiment at the scale and speed we need to unless they're robotic factories. So all of these different technologies are coming into science at exactly the same time. Secretary Wright understands this, and he wants the DOE opportunity to supercharge themselves and make sure the United States stay at the forefront of science. I want to thank all of you for that. Thank you.